welcome to the next video in the hardware portion of Team Ultra 10539's FTC YouTube series. In this video, we'll discuss linear motion in the context of the first tech challenge. Almost every year, some aspect of the challenge revolves around lifting some object some distance upward. In rover rockets, the robots need to latch themselves onto the lander and drop blocks into the lander, which was significantly far off the ground. In Skystone, robots need to lift the blocks in order to build a tower. And this year, in Ultimate Goal, robots need to lift the wobble goals over the front wall in the end game. Linear motion can be accomplished using linear slides, of which there are many variations. Some of the linear slides systems we have found useful are found here, such as rotor slides, the Rev Linear Motion System here, the Actobotics X-Rail, and the Tetrix rack and pinion. This is probably the easiest to use linear slide system that you can buy. It uses these pulleys and bearings in order to make it go up and down. It is a string-based system that works based on the principle that as the string gets shorter, the linear slide gets taller. The strings are placed through these pulleys in such a way that by winding it up, the linear slide system itself will get taller. You can also have the option of inserting surgical tubing in the center of these extrusions, which allows the mechanism to collapse even when gravity doesn't pull it back down. This system is complete as soon as you get it. It has all the parts you need. You still do have to assemble it, but it needs no real further modification to be used on your robot, so it is by far the easiest solution. However, it is one of the more expensive solutions out there on this list, and is often out of stock at the start of the FTC season because it is such a good product. Our team had the most success with this particular system in comparison to all the others I'll discuss later, and it required the least amount of maintenance, and it was the easiest to attach to our robot. However, it couldn't really lift very heavy objects easily, and these plastic guides that are on the top here that go into each of the extrusions break often. So you always need to have a few extras on hand at all times to ensure that during competition, if something breaks, your robot won't be completely stranded. The second system is the Rev Linear Motion Kit, which is much more compact than the X-Rail kit. It's still based on these extrusions and strings, just like the X-Rail. It's just that instead of having this bulky pulley system that you can see on the outside here, it's much more compact. These two extrusions are made into a simple linear slide just by attaching these little Rev linear bearings into the extrusions that look like this. They can slide up and down, and you attach one to each of the extrusions that you want to mount together, and it doesn't take up very much space in comparison. However, it doesn't work quite as well as X-Rail slide kit because the X-Rail is based on these round bearings here that can roll up and down the extrusions, which makes it really, really smooth. However, this is constructed with plastic, and they slide inside the extrusions, which does work well in some cases. However, especially for longer lifts, it's very difficult to make them slide super smoothly, just like how the X-Rail does. This is the major disadvantage of the system. It also requires a significantly larger amount of maintenance, as you will need to tighten the screws that hold these bearings in place between every match to ensure that it doesn't break. It is also constructed with plastic in comparison to the X-Rail, which is constructed with metal. These plastic parts can break pretty easily, so you need to make sure that you're aware of that possibility. Again, like the X-Rail, it can't lift heavy objects, so if you're looking for really heavy-duty stuff, this is probably not what you want to use. Using this particular system, our team also created a custom rack and pinion system that we preferred to when instead of using a string for really heavy objects. So during rover ruckus, when the robots had to lift themselves onto the lander, we use this particular system. So basically what this is it's the same thing as what we had here, but instead of using a string to raise it up and down like the X-Rail, we have mounted a chain on the side of the extrusion. And what this allows us to do is it allows us to attach a sprocket to this motor here, and that allows us to power this movement up and down directly using this motor, which makes it very, very strong. It's able to lift the entire weight of our robot just by using this particular system. As you can see, it still works very nicely as a linear slide. It does still use the Rev Linear Motion System, so you do still have to tighten those screws, although I would say it's less of a issue with this particular method because there's a little bit less stress exerted on these plastic parts, as the lift is shorter and is mostly held in place by this chain. We also have the Tetrix rack and pinion here, which is probably the most reliable system on this list and the simplest. As you can see in this particular system, we have a small pinion gear here, which is turned by a motor that we can mount on the end of this axle here. I'm using a core hex motor in this particular case, which is able to lift the majority of things that you would want to lift with this kind of thing. And on this side of this Tetrix channel, we have this rack of gears, which sort of connects with this gear. So if you can see, as I slide this in here, you notice that the axle that's attached to that gear will spin. So this ensures that when we turn the motor, it lifts it up and down. So it is rather slow, as you can see. It does take quite a while to extend, but it's really great for lifting heavy objects. It's really great for lifting heavy objects, like during relic recovery. We use this to lift the glyphs into the second row of the crypto box. But the disadvantage of this system is that it only works for one stage. So if you need a multi-stage lift like we had on the X rail that's extra tall, this one will only work for as tall as the original system is. However, it requires little to no maintenance and is by far the simplest system. So definitely something to consider if you're looking for heavy objects and a simple system. Lastly, we have the drawer slide system. This is a more custom solution than anything else, but every team will probably need to custom make these to their use case. These are made from drawer slides that you can find at Home Depot. It looks something like this. And make sure that when you go to Home Depot, don't buy this kind of drawer slide. See how this one has this kind of soft close mechanism at the bottom? It's not very useful for using for linear slides, because we don't want this kind of behavior at the bottom where it kind of pulls itself in. What you want is these kind of drawer slides that are just smooth up and down, very, very simple. These are really great because they are super smooth and will lift relatively heavy objects as they're very, very stable. However, the problem is that drawer slides are often made of steel as opposed to aluminum, so this is going to be a pretty heavy system. It's one of the heavier systems that we have on our robot, and also it'll probably require quite a lot of work to create. Our team used Rev extrusions to mount these together. Every team who I've seen using drawer slides has a different solution for this, so this is definitely something that, if you're interested in looking into this, definitely something you're going to have to figure out how to make it work for your team's use case specifically. We used these in one competition, but we found that they were way too heavy and wasted a lot of space on the robot. As you can see, this is not very compact. So we would opt for one of the other solutions that we discussed today. Yeah, so now we can talk about how to string a linear slide. Stringing a linear slide might seem like a very daunting task at first, but in reality, it's quite simple. If you want to mount your linear slide like this, for example, with this particular part of the stage being the bottom, then you want to make sure that you attach your string, you tie your string to the bottom of the last stage. So right here, in my case, the bottom of the third stage. Now, you should have a relatively long string at this point, and what you should do, first thing you want to do is you want to thread the string through the pulley on the stage above it, or the stage before it. So I'm threading it through the pulley on the top of the second stage. You want to make it go around this pulley and come down the other side. Pull the string taut, and then thread the string around the pulley at the bottom of the second stage. Then pull the string through there, and then repeat the exact same process, threading the string through the pulley on the top of the next stage, which in my case is the first stage. And then, if I had a fourth stage, I would thread it through the pulley at the bottom of this stage. But this is my last stage, so therefore, this remainder of this string would now be wrapped around a pulley. So I might use this pulley in this particular case. This pulley is a really great size because it's a good mix between a
between a large pulley, which would increase the speed of my slide, and a small pulley, which would increase the force with which the motor can pull on the slide. So by using a medium-sized pulley, I have a good balance between the two. For maximum power, you might try using a pulley that wraps around the motor's axle directly. For maximum speed, you might use a really large pulley that causes the string to be wound up very quickly. The larger the pulley you use, the less the force will be that you can pull on the string with.